key points to think of whenever you consider a chemical change. A chemical change happens whenever there is a chemical reaction, something like what we see here at the bottom. We start with one substance that we are adding to another substance, and then we get two other substances. That's an example chemical reaction, so it is a chemical change. So when substances combine or reorganize to create new substances, like these, what happened? They reorganized. I had CH4, methane, and oxygen. They reorganized to produce carbon dioxide and water. Another look at it. We have two sorts of particles. The bonds are broken, so the whites here are separated of the black and the reds here are separated. And then we have new bonds forming, with this black one here bonded with two reds and the reds here bonded with two whites. So bonds are broken and new bonds are formed. So that's a chemical change. Examples of chemical change, things to look for: acids acting on substances, something rusting, something rotten, any change involving heat or fire, like cooking or lighting a match, or something explicitly shown through a chemical reaction. Don't feel like they are tricking you. That's a chemical reaction, so it must be a chemical change. Physical changes, on the other hand, they happen whenever matter changes form or shape without changing identity. Whenever we don't get new substances, it's the same substance, but the form and shape might change. Examples of physical changes: phase changes. That's when we have solidification, like when a liquid becomes a solid, when a liquid freezes into a solid. Condensation, when a gas turns into a liquid. Or melting, when a solid turns into a liquid. Or vaporization, when a liquid turns into a gas. In all of these cases, for example, let's take the example of water. This would be ice, this would be liquid water, this would be water vapor. Now, the chemical formula for this is H2O, the same as here, H2O, and the same as here, water vapor as well is H2O. So it is the same substance. The identity of the substance does not change. It's H2O all the time. The same chemical symbol. It's water all the time. What changes is how the particles make up the substance are organized. Their separation. The organization of the particles here is different than here, and their separation is different and even more prominent here. So the separation of the particles of the substance and the organization, that's what changes. But the bonds are staying the same. In this example here, this is not water in the graphic, so we have a green and a blue disk representing a compound. So I still see the same compound in all three cases. The only differences are here they're bound in place. They don't move. We see the dashed line here holding them in place. While here they can move past each other, but they are still the same particles. Here they are further apart, moving more freely, but they are still the same particles. It's just the separation, the motion, and the organization of the particles that changes. Examples of physical changes: Mixing of things, like when you mix coffee with water, tea with water, coffee with milk, that's a physical change. Shredding something, tearing it, cutting it, or breaking it, all of these are physical changes. Whenever the change does not involve a substance change, then it is a physical change.